Hello everyone, this is Jeff GRIB. I'm the developer and programmer for WINGRIDDS, which stands for, again, Windows Gridded Interactive Display and Diagnostic System. These series of videos that I'm creating are designed to help you as the WINGRIDDS user to understand what WINGRIDDS is doing and how it's doing it. And we've already had our volume number 1, which is the introduction to WINGRIDDS. Kind of a quick overview of everything that WINGRIDDS does, and we're going to be creating a whole series of different videos getting deeper and deeper into the operations of WINGRIDDS and things like that. This is video number 2, and we're going to be focusing on GRIB ingest and processing and conversion into the WINGRIDDS data format. WINGRIDDS can't do anything unless it has some data to work with. And so in this video we're going to go into detail to explain everything that the conversion process, everything that's involved with it, everything that it takes to go from GRIB format to the WINGRIDDS format. And it can be kind of confusing if you're not exactly sure what to do, and this will help you to understand what's involved and also help you to customize it if you need to, and also how to troubleshoot if you run into problems. The utility that's used to convert from GRIB data to WINGRIDDS data is called NGRB2PCG32. And we'll go up here, scroll down a bit, and right here, NGRB2PCG32. This is the 32-bit version of the utility application from the original PC grids that's used to convert regular GRIB data and ensemble GRIB data into WINGRIDDS data format. This program is fairly robust. It's been working for quite a while, so it usually does a pretty good job of processing pretty much everything that's out there. It's not going to be 100%, so I'm sure somebody's going to throw something into the works that it doesn't recognize and may cause it to crash or something like that. But it's usually pretty good doing the voodoo that it does, so to speak. We're going to go through the process of what it does, how it does the magic, the configuration files that it reads, and the information that it uses. And so, first of all, within the WINGRIDDS directory, we have these different subdirectories, and data that is downloaded into WINGRIDDS is normally stuck in the GRIB directory and in either the NWS directory, which is a holdover from the original PC grids, or in the WAFs directories. And we'll cover the WAFs GRIB data processing in a separate file or in a separate video, because that's kind of unique in and of itself. But WAFs has all these different sectors for the 8 different sectors that the WAFs data GRIB data is subdivided into. But like I said, we'll cover that later. Right now we're just going to focus on the regular GRIB and ensemble GRIB. And the data files as they're downloaded should be placed in this directory. And here we have some demo files. We just have 2, but for forecast hour 0 and forecast hour 6. But you can have this loaded like as for an example, the climate forecast system goes out to over 4,000 hours at I believe it's either 6-hour or 12-hour increments. So you can get a whole list of a whole slew of data files, GRIB data files that can be stacked in here. But this is where they reside. Now you can configure your system and WINGRIDDS to store the data in other places. WINGRIDDS has that ability to search for that. And if you go into open up WINGRIDDS, go up here into File. We really haven't gotten into these properties yet, but as far as what the ingest and conversion process uses, you go into these WINGRIDDS data directories tab, and you can see there's this group here called GRIB data source. These are the directories where you can define where the GRIB data will be, where the ingest utilities will look for them to find the GRIB data. And these are pretty much the defaults within WinGrids, GRIB, NWS directory. Same thing for the WAFs, WinGrids, GRIB, WAFs directory. And MOS has its own separate processing, so it has its own directory. But you can select different directories, different drives for this to be data to be stored in for whatever reason you may have in your situation. So this is where this is defined at. You can either type it in here, or you can go to select and go search through your system and your different directories to define a different directory for that to be, but we need that to be right there where it is. And the destination for that processed data you can pick and choose also, but for the normal standard configuration within the WinGrids directory, it's called GRIB, or excuse me, Grid Data Directory. And so that's where that data resides at once it's processed with the utility. Like I said, you can redirect that someplace else. But we'll shut that down. We don't need this right now. And like I said, within the GRIB, WinGrids, GRIB, NWS directory, we have our two GRIB files that we will process here shortly. But first, some things to understand when the NGRB to PCG32 first starts up. It reads several different configuration files that it needs to reference to process the GRIB data properly. The first, let's just go down these in order. If you were to be processing ensemble probability GRIB data, let's see what's in here. This is a text file. All of these are text file format, so you can use your favorites, notepad or whatever, to edit these and to modify these, or to add parameters to if your situation arises. But we'll just go over their formats and look at it. And this is all spelled out again in the WinGrids User's Guide, starting at around page 263, I believe it is. And these columns are part of the GRIB2 format. The GRIB format standard went through an update several years ago from GRIB version 1 to GRIB version 2. And GRIB version 2 incorporates many other types of data besides just grid point data. And now they can do satellite data, it can do imagery data, it can do radar data, space information, and so it's much more flexible in the data storage that it can accommodate. And so they had to reformat how the data was defined. And that is what these columns are showing. And if you go and look in the GRIB2 format standard, it's included in the documentation for WinGrids. These columns are associated with the data definitions. The first column is dedicated to the discipline version, the discipline ID. The next column is associated with the category. Category 0, Category 1, Category 2, Category 3, things like that. There's a whole variety of different categories, whether it be for temperature, whether it be for surfaces, whether it be for moisture. All of these different things have different categories associated with them. And then each category has a number to identify the specific GRIB parameter. So discipline 0, Category 1, number 15 is associated with large-scale snow. SNO is the GRIB ID that WinGrids will use if it's processing ensemble probability GRIB data. It will see these numbers in the raw GRIB data, and it will say, I need to use the WinGrids parameter SNO to associate with that data. And so that's what it will do in all of these different things. It's mainly the probability is associated with precipitation or temperature. That's what this is a fairly short listing of GRIB parameters. and then you have the description about what these parameters are, whether it's like I said, these are in usually yes or no, a 1 or a 0 type thing, to show the probabilities in percentages from 0 to 100%. But that's the GRIB2 ensemble prob parm.dat. The next one is what's used with regular GRIB processing. It's very similar, but it's a much longer, notice a much longer list. And I tried to group these into the categories. So again, these 3 columns are the same. Discipline is generally 0. Category 0 is associated with temperature. Category 1 is associated with precipitation. Category 2 is associated with wind, whether it be wind direction, wind speed, vorticity, momentum flux, vertical velocity, things like that. GRIB 3 is associated with heights or pressures. I'm sorry, Category 3. Category 4 is with radiation, shortwave radiation. Category 5 is with long-wave radiation. Category 6 is with cloud cover, things like that, all the way down through. But it's the same, also the same general format. You've got your different categories, your different, the actual GRIB parameter which will be assigned to it once it's processed through NGRB to PCG32, and then a description about what it is. I'll say GRIB2 skip for last. GRIB level. There are a variety of different levels that are associated with the GRIB data, with meteorological GRIB data. And each level ID has a number associated with it within the GRIB message. And so, like go through some of these. A level ID of 6 is associated with max wind. So, level ID of 7 is associated with the tropopause. All of these different things. So when the processing sees a GRIB level of 7, it knows to assign it the level of TROP for tropopause. And for 102 is the mean sea level. 117 is potential vorticity, and all, like I said, again, all of these are defined within the GRIB2 documentation. But this is what NGRB to PCG32 uses to assign a number to a specific level ID that WINGRIDDS understands. Next one down is GRIB model.dat, and again, everything with GRIB identification, parameter identification associated with numbers. Well, WINGRIDDS uses words or acronyms. And so this is to associate a model ID number, numeric, with a model ID alphanumeric. And so let's look through here. So the 068 is associated with the GFS model. It has several different IDs, 77 GFS, 81 is GFS, HRR, the high resolution rapid refresh, is associated with 083. The NAM, North American model, is associated with 084. The WAVE model is 088. And this is part of these. This information is used to build the model or the data file name, which I'll get into shortly. They're restricted to 3-letter alphanumeric letters, characters long. GRIB parm is a holdover from GRIB version 1 in case you happen to process any GRIB version 1 data out there. It's the same thing as GRIB 2 parm, but GRIB version 1 only uses a single number to associate with a specific parameter. So this is doing basically the same thing, but just a single number to identify with a specific GRIB parameter. Like 039 is associated with the vertical velocity and things like that. 013 is associated with a potential temperature or theta. 007 is height, things like that. But this is needed for backwards compatibility to GRIB version 1 if you're going to use that. Grid.dat is a holdover from the original PC grids, which has a grid ID, which shows how the model data is mapped to the planet, to the oblate spheroid of the planet Earth. What I mentioned in the introduction, there's usually the equatorial lat long grid, the Lambert-Conic conformal grid, Lambert-Conic conformal grid, learn to speak right, or the polar stereographic. And so these numbers are associated with a specific grid projection, and then that associates a letter ID with that specific grid ID. And then here's the grid description here. MOS GRIB parameter, that's like I said, if you're going to be doing any MOS, which is again the model output statistics in GRIB1 format. These are the GRIB ID, the parameter ID, and then the GRIB alphanumeric parameter alphanumeric that's associated with that, and then the description of that. So there's a whole list of these. Also, a lot of these are probabilities, but not in the same way that the ensemble is. Going back to GRIB2skip, it has been found, I put a little comment in here, it has been found that every once in a while there will be a GRIB parameter that's stuck in, a GRIB message that's stuck into the GRIB data file that causes the program to crash. And whether it be because the software that INSET provided for processing the GRIB2 data is not quite up to snuff, it didn't get tested, causes it to crash there, or something. But if you find that a specific GRIB message is consistently causing NGRB to PCG32 to crash, you can stick it in here and tell it that when it comes across this GRIB discipline, this GRIB category, this GRIB number, that it will skip it and it'll go on to the next GRIB message, so it won't cause the program to crash. It's part of the troubleshooting process, that it will allow you to see the rest of the GRIB data without it crashing the whole thing. And I've come across these specific GRIB parameters that actually cause the software to crash, and it's been traced, the problem has been traced back to the software library, the GRIB2 software library that INSET provides to the public. And so it's a bug that they need to fix. And they've been told about it. How long it's going to take them to fix it, I don't know. But in the meantime, the program will skip over these GRIB messages if it encounters them. And you can, if you find others, you can add it to this list, and it will skip over that GRIB message and continue on processing, so it won't crash. So, with that in mind, let's look at one of these GRIB messages just real quick so you can get an idea. You can see they're pretty big. They're 23 megabytes and 21 megabytes each. And let's see if Notepad will open it up. You may have to use like a hex editor. Let's see what this does. Yes. Okay. If you notice, every GRIB message is part of the GRIB standard for both GRIB version 1 and GRIB version 2. The GRIB message starts with 3 alphanumeric letters, GRIB. Every GRIB message starts with that. That is defined as the start of the GRIB message. And then after that is the header information that describes the GRIB message, how large it is, the length of it, where the GRIB parameters are mapped, and this is all mapped out and laid out in the GRIB documentation. And this will progress on until it runs into 1, 2, 3, 4 7s in a row. Let's see if it finds it. Swift that off to the side. Aha, okay, cool. This is the end of the first GRIB message, 7777. The GRIB parsing software, the conversion utility in GRB to PCG32, looks for these things. It looks for the GRIB, GRIB letters, and then the GRIB length is defined. It reads that, and then it goes and searches for the 7777, which is supposed to be at a specific location. And if it doesn't see that, it's going to reject that GRIB message. If it sees it, it says, good, this is a valid GRIB message, and so we're going to process that data. And it holds the pointer right there. It grabs the rest of the data between the GRIB and the 7777, and it processes it, and it creates a data message that is then saved in the WINGRIDDS format. Once it's done with this GRIB message, it says, here's the next GRIB ID, and it will continue on until it finds the next 777, and it will progress on through the length of this file, all 23 megabytes, until it reaches the end. Until it reaches the end, and will you stay down there? See, this is going to be cantankerous. Anyway, the last letters, or the last things at the end of the message, are 7777, which shows the end of that GRIB message, which is good. Shrink that back up. In the documentation, in the WINGRIDDS User's Guide on page 25, it begins to talk about the ingest GRIB data process. It describes it, it's a narrative, and so it goes through. And the utility in GRB to PCG32, you can either just double click on it, or you can execute it through WINGRIDDS. If you execute it through WINGRIDDS, it uses the default. It doesn't look for any different source directory or destination directory. It uses all the defaults. It will create a default file name and all of that. But if you have a different setup that is customized and you want to incorporate this into like a batch file or something like that, you can designate a different source ID, designate a different destination ID, a destination directory ID, you can force a specific file name, and you can save the log file into a unique file name if you wish. And so here's an example. The S flag shows the source directory, so you can say, like, we're actually storing the data in the D drive, in the GRIB directory, and you want your destination directory to be the D flag shows the destination directory to be the C drive, out space F directory, and the PCG model.dat file. And so that will, the forecast data will be saved, the model data will be saved as the file name PCG model.dat. And then also, if you show the L flag, the log file will be saved as that as well. So this is adds a flexibility to what NGRB to PCG32 can do. If you have like an automated process, you can build batch files and scripts to execute in this way. There are several different data files that are used in WINGRIDDS. If you happen to have access to some archive data that was originally done with the original PC grids, you'll notice that the data file naming is not the same as what WINGRIDDS now uses. You'll notice that the file naming convention is similar but different. You'll notice that the first two letters are associated with the month, June, July, August, September, October. It will be there. The next two numbers are associated with the day of the month. The next two numbers are associated with the year. Then the next two numbers are associated with the hour of the model run, whether it be 0 hours, 06, 012, 018, something like that. And then a period, and then the three-letter extension, which is associated with the old DOS computers. And that's where that maptype.dat file comes into play to create those. PCG version 2 files are a bit more descriptive. Never know how to talk. The letters for the month is now 3 letters instead of just 2. And then again, it has the day of the month of the model run, the last 2 years, the last 2 digits of the year. Again, the 2 digits of the model run hour, 0, 6, 12, or 18, or something like that. Then you have the 3-letter model name, and then you have the 3-digit grid projection number. And remember, this is taken from the GRIB model.dat and the things like that. That's where that comes from. So these GRIB file names, or the WINGRIDDS data file names, are a little bit more descriptive. If you're processing MOS data, you'd have that little extra MOS stuck in there to separate from regular data. And the WAFs data has its own naming convention, which we will get into when we talk about the WAFs data processing. Now, if you actually process ensemble data, that really gets involved. Everything to the left of the period is the same, but everything to the right of the period is much more descriptive. You get into the 3-letter model name. You'll have an E, just showing that it's ensemble. And then you have other things like showing whether it's a negative, a positive, or a member ID. And then you have the next 2 letters, or alphanumerics, which show if it's the ensemble member ID itself, 0 through 20, and then whether it's a full field, standard deviation, weighted mean, things like that. Again, all of this is all spelled out within the WINGRIDDS users guide. And we'll get into the other naming convention, the other naming files associated with it after we process the data in the demo. But since we are here now, and we have our data, let's go process some data. Let's open up WINGRIDDS. Let's go up here to File. We've already downloaded the data, so let's convert the non-WAFs GRIB data. And since ensembles and regular are grouped in one, we won't be processing WAFs. Let's go convert regular GRIB files. Click on that, and NGRB to PCG takes off. There's a message that's posted for every GRIB message that it processes. It gives the name, gives the processor level, gives the date time group for the year, the month, the day, the hour of the model run, and then this number here is the forecast hour that it's processing. This number is a grand tally of every processed GRIB message that it goes through. You notice it continues incrementing, whereas this number over here starts back at 1 for the new file, and it progresses on and on and on, and we're now at forecast hour 6 here, you can tell. And we'll let that progress on. It's only 2 forecast hours, so we're towards the bottom, so this will be done with shortly. Go through. And then real quickly it showed the inventory, and then it ended. So let's go open this up and see what's there. And sure enough, here's the data file from December 10th, 2017, forecast hour 0. This was the CFS model, which is the CFS is the climate forecast system. And 003, if you recall, is the grid that it's projected on. So this is a model ID of 3. I believe this is the 1 degree grid point resolution for that. And if you notice that this data file here is actually all that it is part of a holdover from the original PC grids, and all that it is showing the inventory. And so this is 6,837 kilobytes large, almost 7 megabytes. If this is if this has a size of 0, but yet you saw everything going past, which shows that the NGRB to PCG32 probably crashed at the point where it was creating the inventory. And the user's guide has a troubleshooting information associated with that, describing that problem and how to correct it. That's normally only associated with the user-defined grids that people download from the Nomads website that Inset provides, that people can subdivide and get subsectors of larger grid sets to download. And NGRB to PCG32 has a bit of a limitation in one area, and that is that the way this inventory file is created as part of a holdover heritage from the original PC grids, the file record size that it writes is defined by the size of the grid area, by the number of grid points. And it has to fit all of the inventory, GRIB parameter inventory, into that area. And you run into a problem if you download a fairly small geographic area with a few grid points, relatively few grid points, but you have a very large involved number of parameters and levels involved in the inventory. So you download a whole bunch of data that's covering a very small area. Well, it's going to have problems with that because it can't fit all of the inventory area into that small record length that it uses to write the file, and so it's probably going to crash. And so the solution to that, and again, this is spelled out in the troubleshooting area of the WINGRIDDS User's Guide. The way to fix that is either to reduce the number of parameters or to increase the area, the grid area, geographic area that you're downloading, to make sure that that fits. And also, as the data file is created within the model directory, if you notice, go back, there is a model subdirectory which is in the grid data directory. This was created in association with this data file. If you notice, it's 2017 12 10 0. And if you open that up, this is where the actual gridded data is stored after it's been processed. You'll notice, spread this open a little bit wider, you had 2 forecast hours that were processed. You have 2 data files that are here, which shows the model name, the grid ID, and the forecast time. Forecast hour 0, forecast hour 06. There's also an inventory file that's associated with these, and you could have a list of forecast hours going out, like I said, again, 4,000 hours, but you'll have a single inventory file here, and this is the detailed inventory that's actually used, that WinGrid searches through to retrieve the data when you request it within WinGrid's operations. So that's what that. So if you want to save this sometime use in the future, when to get it off the system, so you're going to have to save this file, save all the contents of this directory. And also, if you have multiple different model runs that will run at the same date, or maybe at different times, like a 00Z run, a 06Z run, or a 12Z run, things like that. Or if you have different models like the GFS and the NAM, ECM, WF, all of that will be grouped within this datetime group. They'll all be included within this directory under different names. Probably in a future version of WinGrids, I'm going to have a utility written so that you say, I want to save this file. Since this is what is displayed, this file name is what's displayed within WinGrids down at on the border and things like that, as to identify the file that's open for processing. I'm going to create probably write a utility at some point in the future to, if you want to save this file, it's going to go through and search within the model directory what datetime group that's associated with it, what directory, and what files are associated with it, and save everything into one, whether it be like maybe a zip file or something like that, to make it easier to some sort of compression to group it all into one file. Now the only potential problem with that is if you have multiple different files, and especially like with the GFS is getting up to like a 1/4 degree resolution, you can have files that are 2 or 3 gigabytes large potentially. Well, you can't fit all of that data into a single data file within Windows, 32-bit Windows. It'll only identify files that are 4 gigabytes or less, and so something to keep in mind. That was the reason why we went to this new data file format, is so you can ingest and process large volumes of data, still keep it organized and still keep it usable within the 32-bit Windows, because of that 4 gigabyte limit. But let's open this data file. We double click on it. WinGrids draws the map, and there's all of your parameters. HHC wind, let's show 500 millibars, and there it is. So that's an example of how WinGrids processes GRIB data and converts it to WinGrids format. One last thing, in GRB to PCG32, when it runs, it creates a log file, a detailed step of everything that it does in processing each GRIB message. Let's go back to this. And so if you have problems processing data and you need to pass that, you want to you have a report a bug or something like that, you need to include this file with it. And this is in the WinGrids directory. If you go down to, where is it at? In GRB to PCG32.out. This is the log file that the program creates as it's processing data. So let's do a real quick look at this to orient you with this. There's a little header that shows the version. The current working directory is WinGrids off the C root directory. If there were any arguments, like what was in, go back up here to the to where it's executed. If any of these arguments were included, instead of just saying run it in standard mode, those arguments would be listed here. The source directory, destination directory, things like that. But since nothing was modified, the output data directory is WinGrids grid data. The source directory is WinGrids GRIB NWS directory. And then it starts processing the data. It shows the first file it's opened. It says, hey, new GRIB data file opened. And it has it reports the pointers at the start of the file. And then it finds that those 4 characters, GRIB, it says, I found it, and it's edition 2, GRIB edition 2. The record is record number 1, GRIB message number 1, and its size and how many, nearly 69 kilobytes. And then it shows that it's a JPEG compression, and so it's going to be decompressing the data using the JPEG standard. Going on down, it reads the raw GRIB2 parameter is pressure, PRES. Shows the GRIB2 GRIB level is 102. And sometimes the GRIB navigation has to be modified to keep everything pointed north, if you will. And so it shows that is reading from the grid description section. These are some navigation information. And it shows that on down, and it shows that the north and south is getting swapped. And so it's getting essentially inverted. And that's what that 192 is being changed from a 0 to 192. Then we go on down the KPDS, the product description section. This is a holdover from the GRIB 1 version. Shows all of this information. Number 7, I believe, is the ID center. 98 is the model ID, and then it goes on through the different things. It shows the level top and level bottom. The GRIB to here the identification of the actual GRIB parameter, showing the discipline, the category, and the parameter number is 030, and that shows that it's pressure. And it shows that the year, the month, the day, the hour, the forecast hour shows the year is from 2017, from December 10th, 0Z, and this is forecast hour 0. So the parameter is pressure, mean sea level. It creates the data file name from that. It says that nothing previously existed, so that's good. And then at first, for the first GRIB message process, it has to do some additional processing separate. It creates these additional GRIB or grid data messages for MSG0, MSG1. These are things holdover from PC grids. Essentially, a grid of all zeros and a grid of all ones. Then it gets into the map projection for the navigation. It stores all that information. And from that, it creates a grid of latitude, a grid of longitude. DMAP is the grid spacing. FFFF is the Coriolis parameter, which is used in projecting wind. EDIR shows the grid direction. GRDX and GRDY shows pretty much a grid of the grid points, starting at 0 going to maximum, and the X direction is left and right, and also in the Y direction, which is north and south. And so it shows that pressure MSL, that was grid number 1, so it does those 10 or those 9 extra grids, and then it goes through and goes back and resumes the processing. And for everything that's satisfied, it saves it, and it goes on through, on and on and on and on and on all the way down, all the way through, till it gets to the end. Let's page up some here. It gets to the end, the processing is complete, and then it starts creating the inventory, saving WinGRIDS inventory records. So data forecast hour 0 in this file, it starts saving all of the inventory in there. And then for forecast hour 6, it lists all of the inventory there. And since those are the only 2 files that we processed, those are the only 2 that are listed. However many forecast hours are processed, they'll all be listed here. If this information is missing, say for example, it gets to this message, saving WinGRIDS inventory records, and nothing is after that. Again, that shows that it crashed trying to create this inventory and write this inventory information to this file, and there was not enough room. So that's an indication of that. But it gets down to the end, and total ingest errors are 0, which is good, and then everything was successful. Like I said, we've already gone through and shown that the data is there, so that's good. All of the parameters are there, and that's good. And that is how you process GRIB data for WinGRIDS. And I hope this explained a lot, and it didn't get too long and drawn out, and is usable for you, and it helps you to understand what's going on, and if you run into problems, it helps you to troubleshoot. So thank you very much, and probably the one next in step will be processing the WAF's grid. So that's similar but a little bit different, but stay tuned for that. Don't want to let too much information loose ahead of time. So thank you very much. Have a great day.